Everything that has a beginning must have an end. But what does that mean for the universe and for time itself? The end of the universe is a topic that blends astrophysics, cosmology, and existential reflection. Will it collapse into itself, fade into darkness, tear itself apart? Each scenario paints a very different picture of the ultimate fate of all things. Let's start by understanding the universe's current trajectory. Thanks to observations of distant galaxies and Type Ia supernovae, we know the universe is expanding. And not just expanding, but accelerating in its expansion. Galaxies are rushing away from each other faster and faster, driven by an unseen force: dark energy. This expansion has profound implications for the future. One of the most widely accepted scenarios is called the Big Freeze, also known as heat death. In this model, the universe keeps expanding forever. As it stretches, galaxies move farther apart, stars burn out, and energy becomes evenly distributed. Over trillions of years, the universe cools to near absolute zero. No stars, no light, no motion, just a cold, dark void. Time would continue in this scenario, but everything meaningful within time would cease. But there are other possibilities. The Big Rip. In this more dramatic model, dark energy doesn't remain constant. It becomes stronger over time. Eventually, its repulsive force overcomes all other forces in the universe. First, galaxy clusters drift apart. Then galaxies themselves tear apart. Then solar systems, planets, even atoms. Space would stretch infinitely, and time itself could become meaningless. This rip would signal not just the end of structure, but the end of all information. Current data suggests we're not heading directly toward a big rip, but if dark energy evolves unpredictably, it's not off the table. The Big Crunch. This is the opposite of the Big Rip. Instead of expanding forever, gravity eventually halts the expansion and reverses it. Galaxies begin to fall back toward each other. The universe contracts, heats up, and eventually collapses into a dense, hot singularity, a mirror image of the Big Bang. This idea was more popular before the discovery of accelerating expansion, but some modified gravity models could still make it possible. If the universe ends this way, it might be cyclic, with a new universe bouncing out of the crunch. The Big Bounce. In this theory, the universe undergoes endless cycles of expansion and contraction. After each big crunch, a new Big Bang occurs, potentially with new physical laws or constants. This could align with ideas in loop quantum cosmology and even echo ancient philosophical views of eternal cycles. If the Big Bounce is real, we might be living in just one iteration of a multiverse carousel. And our cosmic story could be just one of infinite chapters. Vacuum decay. Here's a wild one. According to quantum field theory, the vacuum we live in might not be the most stable version possible. We could be living in a false vacuum, with a more stable true vacuum waiting to be triggered. If that happens, a bubble of true vacuum could form somewhere in the universe and expand at the speed of light, erasing everything in its path instantly. No warning, no pain, just nothing. The probability is low, but the possibility is real. This scenario is linked to the Higgs field and potential energy states in the Standard Model of physics. Now, let's take a moment to consider time itself. In these scenarios, time keeps ticking. But what if time isn't fundamental? What if time is an emergent property of entropy and order, something that only exists while there's structure, motion, and change? In a heat-death universe, where everything is evenly spread and no more work can be done, would time still have meaning? Without change, there is no before or after, only a frozen present. And if time ends, does it end for everything or just from our perspective? Some speculative theories suggest that new dimensions could emerge after the end of time, that a deeper substrate of reality might exist beyond space and time as we know it. In this view, the universe never truly dies. It transforms into something we cannot yet imagine. From a human perspective, these scenarios are overwhelming. The timescales involved, billions, trillions, even Google years, are far beyond our lives, or even the lifespan of our species. But contemplating the end helps us better understand the nature of beginnings, and it reminds us of something profound: impermanence. Everything we build, everything we know, even the stars themselves, are temporary. But in that temporary existence lies a kind of beauty. The universe is not static, it's dynamic, evolving, alive in a way. And we are part of that process. Perhaps the end is not something to fear, but something to marvel at, a final act in a cosmic story still being written. At Infinity Beyond, we explore these questions not to find all the answers, but to expand the space for wonder. Whether the universe ends in ice, fire, silence, or surprise, we are here now, aware, conscious, asking questions no other known species can. In our next episode, we'll look at what comes after endings, from rebirths in quantum cosmology to speculative ideas of what might exist beyond our universe. Subscribe to Infinity Beyond, and let's keep exploring, even the end.